Hello students, welcome to EduCell. In this video, we are going to discuss about Quicksort. So, in general, the questions are being asked repeatedly in competitive exams as well as in GATE exams about the Quicksort, like what are the passes are existing or in pass 1 or pass 2 or pass 3, what are the values, as well as the questions are what is the worst time complexity and why we are getting the worst time complexity in Quicksort as in square, as well as what is the average time complexity and the best time complexity. These are the part of our today's discussion. We will be discussing that one. Next, this content I have collected from Corman. The book name is Introduction to Algorithm, written by Corman and other co-authors. Basically, in these videos, I am following two different books. One is Tados, written by the Tados and other co-author. Another book is Corman and other co-authors. So here, A stands for array. Okay. P stands for the first index. R stands for the last index. One more request to those who are new for this video, kindly visit or kindly watch other videos which are relevant to the divide and conquer approach, which will be more easier for you to understand, like how merge sort is working, as well as how counting inversion is being done, as well as how divide conquer approach we are following. That part could be a more interrelated while you are watching this quick short video. Okay. Next, P is less than R means, as we have already discussed, if that we said R is last index and P is the first index. If there is one index, it means like if P is equal to R, means there is only one index. And one index, any number if you can put here, so we will say it's by default sorted. Why? Because we cannot say one person in a class is first or last. We cannot define, because there must be a comparison to say whether it is like we are doing sorted or we are doing sorting, might be ascending order or descending order, but that's sorting based on some comparisons. Here we are not going to do any comparison because of only one index is there, means one student inside the class. So we cannot say whether he or she is first, stood first in the class or stood last in the class. We cannot compare. The one element we say is by default uh, sorted for us. If this condition happens, so what we have to do, we have to find the partition we have to find, but q will keep the position. Basically it keeps the position of pivot element. Okay, so don't worry, we will be discussing what is pivot element, position of pivot element. Okay, so pivot element is just an element for us through which we will do the comparison. Once we'll pick some element as maximum while finding the maximum of an element of an array. Suppose you're finding which one is the maximum element present inside an array. In general, what we are doing, either we can fix the first element as our maximum element, or the last element is a greatest or maximum in weightage. Okay, like if you want to find the greatest element among all the elements present inside that array, once you try to find out the first element, initial element, you first say is the greatest element among all the elements that you assumed. Okay, so that the same assumption we are doing while sorting it. We will keep the pivot element as for certain element through which we will do the sorting, like we will do the comparison with it. So here Q stands for the position of pivot element. In merge sort, we are just simply putting P plus R divided by 2 with a lower function through which we are getting the mid value of it. But here the no need for any mid value. We are simply using the position of pivot element. Once we got it, then the left hand side, you must say it's left hand side. Left hand side will be keeping up to Q minus 1, and then q will be at the position of pivot element as we got, and q plus 1 will be the right hand side of the quick shot, which we will be doing in future. Okay, so I kept the partition algorithm here. In this partition algorithm, it is as we have already defined. This is the first one. P stands for the first index, R stands for the last index, A stands for the array. Okay, so here X is the pivot element. X is the pivot element for us through which we will find the element to be compared. Means the last element we are fixing as the pivot element. As for this example, I kept from the uh, Corman book. So here this is our X, okay, or you can say the last index we first fixed it. I must name this as X. Why? Because it's a pivot element for us. Next, I stands for the value of I will be p minus 1. Initially, we know p is the starting index, which is 1. The first index has said to be 1 here in Corman. So I minus 1 means, sorry, p minus 1 means 1 minus 1, which is 0. Zeroth index is, this index is considered as zeroth index for us. Initially, we have to do the first step is like this. Next, j will be starting from p to r minus 1. Why r minus 1? Because r is our pivot element. So that's why we are not keeping r up to r minus 1. Up to this position, we are doing the comparison with the fixed pivot element which is at r. Okay. Next, if a of j, like j will be from p to r, like j is at p means at initial stage, it will reach to r minus 1. It will compare with r. Okay, once it found less than or equal to, I value will be incremented to 1. Okay, so now exchange, once we have done it, now we will exchange with ai with aj. Okay, next, once it is done, so we will say the exchange or the swap between the numbers, like we will be swapping with the position of I what was there before with the last index. Once this portion is done, the this portion, at this portion we must say a pass is completed, we must say at this position, and after that we will return I plus 1. This will be done, like we will be just going through the example that will be very much understandable points for us to get the proper idea how it is being done. Okay, like the first for loop says we will run it towards r minus 1, then we'll compare, then we have to add the I value as 1, then we exchange. Okay, so here I'm just uh, keeping the red as just we started it. Here in this portion, like we started with the j values are 2. Now we have to check whether 2 is less than equal to 4 or not. If yes, then I value was before 0, that will be incremented. Okay, so here I'm just citing or referring. Here I value will be I plus 1, which is 0 plus 1, which is 1. Now, so the exchange will be done. Exchange with what? I, what the I value will be, like I value is right now a of 1, will be exchanged with, previously j value was also 1. So a1 with a1 means the same position it will be having, like 2 previously was there, so the 2 will be like this. Okay, so here I was previously at this side, I was incremented. Once it is completed, now j value will be uh, at second position. Why? Because we have completed this and j value was before p, and once a completion of one loop or one iteration, j value will be p plus 1, means it is now in second position. Clear? This is what exactly the second step we are working. Now we have to do same thing. Now I'm just omitting it. Previously I value was 1, and we have to now check 8 whether 8 is less than equal to 4 or not. If no, what we have to do, we have to ignore that for a while, and we will run the j value was previously p plus 1. Now it will be like p plus 2. Clear? Now index is changed. We are not doing anything. If it is not less, so we will not touch it. If it is greater, if it, or else you can say if it is greater than the pivot element, we will not check it, because as a approach of quicksort. Next, what we have to do, j value is at third position and R is fixed for us. Now we have to go for a checking whether 7 is less than less than or equal to the pivot element or not. Here we know 7 is not less than 4, so I value remains same, but j value will increment. J value previously was p plus 2, now it's p plus 3. Right now we are having in this location. Here we have to check again the value 1 is less than equal to 4. Once it is done, so we must increment the I value. I value was previously 1. Now 1 plus 1, the I value is 2. So I value here I must say I with 2 with J value previously was here like 1, 2, 3, 4. Now P was previously I must write it 1 plus 3 because P is the initial one. So J value is 4 now. So we have to just exchange it. Like 1 will be at 8th location and 8 will be at 1st location. In the next step, it reflected well. Okay. Once it is done, so J value will increase to 4 instead of 3. So now J value is 5 and we have to check again whether it is less than or not, or less than equal to with the pivot element or not. We found yes, it is less than the pivot element. Once it is less than, so what we have to do, we have to just increment it with 1. So I value with 3, now I have to write it 3, and though we exchanged it previously, it was there 1 2 3 4 5, like it was there with a 5, so 5 with 3 will be exchanged. Like here it is 3 and here, clear? So this is how we have to do the swapping. This is how it is running. Once it is done, so the next J value is at 6th location. J value is at 6. We have to check whether this 5 is less than equal to 4 or not. If no, so you forget, you do not touch it. You simply increase the J value. Now we are at this 6 means 7th position. J is at 7th position, like up to R minus 1 we have to run, means up to this position we have to run, and we have to check whether 6 is less than 4 or not. Here we found no, it is not less than, means the loop is completed its work. Now after completion, like after this 3, 4, 5 and 6 steps, what we have to do, outer of the for loop we will exchange. Previously I was 3, now I will become 3 plus 1, which is 4, and 4 here I must write this condition I plus 1, like 4 plus 1, 4 plus 1 with AR. AR was previously 1 2 3 4 5 6 7 8. R is at 8th location, so we will just exchange with that. So here in 4th position it will come and 8 will reach there. This is how it is being done. Once a pass is completed, how do you know? You have to first check whether the pivot element, I must write it is X. This side, the left hand side should be less, or lesser value will be existing at the left hand side and higher value will be at the right hand side of the pivot element or the selected pivot element. We will say the pass is completed. You must say this is a pass 1 for us. Means one pass is completed, means we have shifted the pivot element. Once the pivot element is shifted, we have to check whether the condition is following. Once it is done, we must say pass 1 is completed. Now here the position of pivot element is at 4th location. 1 2 3 4 is at 4th location, so we must say Q is 4th position. Once we found it 4th position, the left hand side will be, I must say, QS for Quicksort. Next we must say 1 2 3, which is Q minus 1. So A starting from 1 because P, and 3Y because Q is 4, so we must say it is 3 now. And Quicksort A, that previously it was 4th position, now from 5 to 8. Here you can check 1 2 3 4 5 5 here 7 is fifth position. Next, sixth, 7 5 6 7 8. R is at 8th position. Okay, these are the value inside it. We are not exactly considering the value, we will be focusing on the index of it. Now I have to run. As for it, we have to complete the ls left hand side, then we will focus on the right hand side till it completes its work. Okay, now it's I. Now we have to complete the j. So 2 1 3 4 7 5 6 8. So the left hand side I must write as green. This is our left hand side and this is our right hand side. Right hand side I must color it in this way. This is our right hand side. Okay, now we will be first completing the left hand side. For left hand side we must say it is our pivot element. For the timing, it is our pivot element, and others are here. We started I as here and P points to this, J points to this. Now we have to compare whether 2 is less than equal to 3 or not. If yes, so what we have to do, we have to enhance. The I value was before 0 with the 1, now I value become 1. So here we will point the I. Once it is done, so A of 1 with A of j, A of I with A of j means A of 1 with A of 1 again, means j value is at 1, so no need to change it. We'll simply wait. Then j value will be incremented to the next variable. Why? Because for loop, within the for loop we have to reach at least the next means previous to the pivot element. Here we have to check whether 1 is less than equal to 3 or not. Yes, we found it. So what we have to do, I value was previously 1, now it will be incremented to 2. So once it is done, so A of I, which is A of 2 with j value is at 2, so we must say A with 2 with 2, means the I value points to here. Clear? Means we reached here, no need to update it because the pivot element is at its own location, means it's fixed at its position. Now after the for loop, what we have to do, I plus 1 with A of R. After the for loop, I plus 1 means I was previously 2, now 2 plus 1, which is A of 3. A of 3 with A of 3 means no need to change it. We say we have completed, but we are not changing it. Okay, now I must write it. I'm just rewriting it. Now the value we have checked and we must write here, they remain unchanged. 2 1 and here is 4 7 5 6 and 8, it remain unchanged, but we have done it. So this is our pass 2, and here the lesser value is existing there and the greater value is existing that side. Now we have to run the left hand side again because it's within its location here, left hand side, until we will stop until one element is existing at its right or its exact position. Here it is our pivot element for the time being. Now P and J is at its own location, I is here because P minus 1. Now we have to compare. Once we have to compare, we have to check whether 2 is greater than whether 2 is less than equal to 1 or not. Here we know it's not that one. If not, so what exactly we have to do? So we have to simply switch to, we have to stop here And what we have to do then the for loop ended here, and once the for loop ended, so a of I plus 1 with a of r. I was previously 0, now 0 plus 1, which is 1, a of 1 with a of r is a of 2, means exchange between 2 and 1. This is what we have to do, because after the for loop it will be running like this. So what we have to write then, I'm just changing it, and I must do one more thing like L, okay, through which we will be finding the pass. The second pass we found after running this, we found pass 3 as this is L. So here I must change the color 4, 7, 5, 6, 8. Color will be 1, 2, because here we found nothing is there but greater value is there. So this is our pass 3, and here we must write the color for 3. Next, the color for here is right from right. We say this is sorted now. We have to first pick this is our pivot element. Though we pick this as our pivot element, now we have to compare with the rest of the elements, like here I is pointed and here P is pointed and J is pointed. Whether 7 is less than 8 or not, yes, it is less. So I value will become I plus 1, like it was before 4. Now I value is 4 minus 1. I go sorry 4 plus 1, which is 5, like fifth position. I will point to the fifth position, and J was previously at fifth position, so A of 5 with A of 5, so no need to change it. Now J value will be changed its location after this comparison. After this, J value we must have to compare with the element, like fifth element, like the sixth element, like which we have is 5, whether it is less than 8 or not. Once it is less than that, previously I value was 5, now I value became 5 plus 1, which is 6. Okay, like A6 with AJ, like AJ is also at this location, means here is I and here is J. No need to change it, rather than we have to wish skip that for a while, because we know 5 as its own location. If we'll exchange means no, we are not exactly doing anything. Now after this, J value will be incremented here. Now J value is at 7th position. We have to check whether 6 is less than equal to 8 or not. Yes, previously I value was 6, and 6 plus 1, which is 7 now, and 7 here I must change it. I value is pointing that, and A7 with AJ is 7. So I'm just following the algorithm based on that I found. So we stopped the for loop for a while, and we say the position we are not changing it. And what we have to do, I value was previously 7, because we updated that was 7. So 7 plus 1 with A of r, which is 8. A of r is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is what we found as 8, means A8 with A8, means if you're swapping the same object, the same where we are doing, it is at its own location. Done. So we are not exactly uh, changing the location, we will be keeping the same position, but we have to write the element again to say the pivot element is at its correct location. We'll just write that one. Okay, now I have to just mention one more M. Here I must write 4, 7, 5, 6, and here is 8. I'm just maintaining the color through which we are getting the value. Here is 3, here is 8. Okay, this is what our pass 4. Okay, next we have this left hand side which is not yet sorted. Okay, so to sort it we must say it's our pivot element which is x as per our convention here in Corman. So we point I there and P initially, P with the J same position, whether 7 is less than equal to 6 or not. If no, so we are not changing its location. I was previously at 4th location, keep that as 4th location. So now the J is pointing to this location. Now 5, whether 5 is less than equal to 6 or not. Yes, we found it is less than 6. If less than 6, so I value will incremented with 1. Now I value become 5. So we will exchange 5 with the J value which is 6. Like this is 6th position. 1, 2, 3, 4, 5, 6. J is at 6th position. So we must write A5 with A6. Now we change the point, I pointing there. So what we have to do, the exchange between these two values. Okay. Once we are doing, so here 5 will come and here 7 will come. Now what we have to do, we have to just check, like here the stopping criteria we found and I value is at this location, is at 5th location. Now the for loop ended here and what we have to found, like I plus 1 once for loop is ended with this, with a of r. A of r was previously at 7th location, a of r. So a of I was 5, 5 plus 1 with a of r was 7. So now a of 6 with a of 7. Like 6th with 7 we will be again swapping. Okay. So again we will do the swap. Once it is done, so what we have to do? We have to just use another array for it to represent. I'm just changing the color. So here 5, 6, 7 I must write pass 5. Okay. So here it is 1, here it is 2. So here it is 3. Now here it is 4. Here it is 8. So this is how we completed the quick short. This what exactly we found. We must discuss about the complexity of it. So complexity, for finding complexity I'm using red pen again. So here the partitioning, whenever we are getting the partitioning is through which we got the for loop is getting used. For for loop the time complexity is big of n. Because of for loop we are using here up to n minus 1 you can write. As per the formula we should get we should say it's n minus 1, but n minus 1 is equivalent to n because we know some constant is getting subtracted or added. We are just ignoring that, rather than we are just considering the bigger value here. Next, so the q we found using big of n. I'm just writing here time complexity. So here we are getting big of n. Why? Because we are finding the position. Next, though it is a recurrence, the recursion, through recursion we must say it's a recurrence relation. So Tn by 2. So as per this, the recurrence relation could be recurrence relation could be written as T of n equal to 2t n by 2 plus big of n, or in general you can write it is as n also, not an issue. So this is for our best case, best and average case. Why that you know? Because recursion we are using, and it's the half, like left hand side and right hand side, it's divided by the two, because we know we have to first divisible, like we first find out the q, then based on the q we are dividing two halves. So based on that, as we found the time complexity of it, so the time complexity is n log n. And why I'm saying best and average case as big of n, I'll just simply discuss here in this case, like in path 3, whenever we are comparing, once it is already in a sorted, means once the pivot element is at its perfect location, we have to just comparing with other elements like n minus 1. You can just check for the worst case why we are getting other time complexity, means why we are getting n square. You just check here. So in worst case, basically, if an element, we can say, suppose there are four elements, 1 2 3 4. If we say it's a pivot element for us, once if we are saying pivot element, we have to first check from this end to that end. Means if there are n number of elements, if n number of elements, the comparison we are doing, the comparison is n minus 1. So we are doing, for n number of elements, we are doing n minus 1 number of comparisons. So that is why, like we in pass 1 we found, yeah, it is okay. Next in pass 2 we found, like we have focused on this third, like here. So here we say we have to do the comparison. As we have to fix this as our n, then n minus 1, again we do the comparison. Like once we are going for from starting end to the last end, if sorted, so the number of paths we will be saying, like the number of elements. If sorted, if sorted, the number of elements is equivalent to the number of passes. Why clear? For the first one, the 4 is at its own location. Next for pass 2, like 3 is at its own location. For pass 3, like 2 is at its own location. For pass 4, 1 is at its own location. This is what we are getting. So though we are getting it, the time complexity could be n into n minus 1. So which is n square. So we must write the time complexity as this. Okay, so n square we are getting instead of n log n, because it is sorted. We are getting the worst time complexity though it is sorted. So I hope it is clearly understood by you. So what exactly we are getting and why it is, and the recurrence relation for it is, the recurrence relation for worst time complexity is Tn equal to Tn minus 1 plus n. This is what the recurrence relation for our worst time complexity. You please remember this one, because there are two different recurrence relation is getting observed, through which we are getting the complexities. Okay, worst time complexity we are getting because of this. So I hope it is clearly understood by you. If any doubt you will be having, please comment below. Thank you. Have a good day.